surface area of spheres, cones and pyramids. So the surface area of a sphere, we use the radius of course, and it's 4 times pi times the radius squared. Don't get the surface area formula mixed up with the volume formula, 4/3 pi r cubed. Don't get it mixed up with the circle area formula, just pi r squared, so you do have to get the correct surface area for a sphere. The cone formula, again, uses the radius, and you can see that a cone consists of a circle and the wrapped around curved part. So it makes sense that your surface area of a cone includes pi r squared, which is the circle part, plus pi times the radius times s. And s is the slant height of the cone. Now in the volume, we're used to using the perpendicular height of the cone right down the middle, h. So this is the slant height. It's the side edge there. It's different, and you've got to remember that this is s, not 5. So this is the surface area of a cone. If you had an open cone, as in no circle on the top, like an ice cream cone, you'd leave out this part. So this is the circle, this is the curved surface. Now the only pyramid that we'll learn to find the surface area of is a square-based pyramid. And a square-based pyramid, of course, has a square at the base and then 4 identical triangles. And so we need the area of all of those. So we've got the base length of our pyramid, and we also have the height of each triangle, not the perpendicular height of the pyramid, which we use for its volume, but the height of each triangle, because we need that distance there, the base and the height of the triangles, to get the area of the triangles. So it makes sense that our surface area has the base squared to give us that square area, plus 4 times half base times height, which gives us the triangles. And obviously 4 times a half is 2, so if you prefer to use base squared plus 2 base times height, that will get you the surface area of a square-based pyramid. If you prefer, you're quite welcome to use this version. So I've started with a hemisphere to find the surface area, because we'll have to be a little bit creative with this one, so I figure you can probably work out the sphere quite easily. Sorry, the light's gone funny. There we go. A sphere is nice and easy, 4 pi r squared, so the surface area of this, we'll have the surface area of a sphere, 4 pi r squared, and we only want half of it, so we'll divide by 2, plus this hemisphere also includes the circle at the bottom, so we'll also need pi r squared for the circle. Now, if you want to be really clever with this, you can see that this is 2 pi r squared plus pi r squared, so it's going to be 3 lots of pi r squared. If you prefer, however, just to work that out, 4 pi r squared divided by 2 plus pi r squared, that's fine as well. Remember, our radius is half the diameter, so that's 8 centimeters. As I said, we could simplify that down, that would be absolutely fine. Dodgy calculator here, but if we prefer to think of this logically, now remember 4 divided by 2, so I've got 2 overall there, 2 times pi times 8 squared, which is, of course, that's 64, plus pi times 8 squared, 603.2 centimetres squared, remember, for surface area. So do remember, we could have simplified that formula down a bit. I just took it the long way around because I know some people prefer that. It's a grubby calculator. A cone, remember, our surface area for a cone is pi r squared plus pi r s. I have a very bad habit of thinking that this s is going to be a power. You see, I almost wrote that there. It's pi times r times s. It's not s as a power. Be very careful there. Pi times 6 squared plus pi times 6 times that slant height of 10. And you can just type that in. Pi times 6 squared is 36, plus pi times 6 times 10 is 60. And I've got 301.6 meters squared. So that's a hemisphere, a cone, and a square-based pyramid. So you remember our surface area is the base squared to get the square bottom, plus 4 times a half base times height. That's 15 squared. Now 4 times a half is 2, times the base, 15, times the height of the triangle, 6. And type that in. 2 times 15 times 6, and I've got 405 millimeters squared. So it's really just a case of remembering the correct formula, checking if there's been any changes to the shape that mean you have to change the formula, typing in your numbers and getting it right, and recognizing, of course, that the slant height of a cone and the height of the triangle for a square-based pyramid.